everyone, welcome to tutorial lecture of week 9. In the previous summary lecture of week 9, we have talked about multiple different types of impact analysis and all, and in the assignment we have discussed that we can make prediction of crop yield or impact on food because of climate change impact. So we can how we can solve this particular problem. So we have discussed about how to assessing the impact of extreme climate events on food productions. Okay. So suppose so what is basically, we are trying to look at here the extreme events, and then we are trying to look at how these extreme events are going to affect the crop yields or basically their food productions in a different parts of the region. So we will discuss a very simple example. We will discuss a very simple example where we will discuss about how to make a simple mathematical model, and we can use some sort of a known data set with parameters, and that can be used to predict if there is some sort of extreme conditions, drought or heat waves, for example, how these drought and heat waves are going to affect the crop yield of particular location. So the learning goal of this particular assignment is so here we will basically discuss about we will look at how extreme events like let us say heat waves and let us say drought affect crop yield. The second objective of this particular tutorial is we will apply a parametric model, a very simple parametric model to estimate crop yield. And the third is basically under let us say extreme climate conditions. So first we will try to look at only drought event, and then we will also include heat waves and drought at the same time. That is kind of a compound extreme problem. And then we will the third objective is basically we will simulate the crop yield under different climate scenario. So first of all, if you know that the parameter value, we would be able to do that for different scenarios as well. Or fourth is basically way forward, how we can make more sophisticated equations like that, so that we can basically reduce the uncertainty which are there. So these are the learning goals of this. First we will try to look at how extreme events are likely to influence the crop yields. Let us say you can take any crop, major crop, and then we will apply a parametric model. Parametric means there is some parameters, some variables which we know, values which we have observed from different types of observational techniques like that, and then we will estimate crop yield under extreme climatic conditions, and then we will simulate the crop yield, that climate scenario condition, and then we will discuss about what could be the future pathways when we are dealing with this kind of the model. Okay, so let's make a very simple equation for crop yield. How do we do that? Let's say we are saying capital Y is the crop yield during climate extreme scenario. Okay, and this is the Y max when we have crop yield during non extreme climate condition, normal condition particularly. So, how do we relate these? How do we make a sort of equation which can be relate to the crop yield which is during the normal condition and during the climate extremes? So, we can make a equation like Y is equal to, let us say, Y max multiplied by, let us say, 1 minus alpha t. I will explain all of these terminology. Then we have dt minus alpha s multiplied by, let us say, 1 minus sm. Okay, we can close this bracket, we can close this bracket, plus some sort of error terminology. Now, what is alpha t? Alpha t is basically, let us say, we can say the crop yield loss rate, let us say, per heat stress conditions days. Let us say we can take it this value as 0.02 tons per day or something like this, and let us say this alpha s is basically a parameter which is sensitive to soil moisture. Okay. So, for example, we can take this value is 0.3 like that. Then let us say the alpha t we know, that is rate under per heat stress day. What is dt? dt is basically can be defined as the number of days above a critical temperature. So, what do we mean by critical temperature? Let us say we have drawn a particular threshold and we are looking at how many times it is crossing a particular threshold like that. So, that is we call the critical temperature, number of days. You can count the numbers and then we can calculate what is the total number of days where it is exceeding above the critical temperature or thresholds like that. So, this is dt, alpha s. Now, sm is basically we can explain is basically soil moisture index, probably we can take. Okay. So, soil moisture index is it can be vary between 0 to 1, or if it is 1 then it is kind of fully saturated soil, or if it is 0 that is completely dry soil. So, this is a kind of a equation formulation we can do. So, we have So, in the new page I will write again this equation. So, basically it is the y is equal to y max. So, is the function of the maximum crop yield during the non extreme conditions, the parameter alpha t is basically the rate at which it affects the crop yield during the heat stress days, number of days which are above heat stress minus alpha s, which is a soil moisture parameter, which basically tells about what is the sensitive, this parameter is basically related to the soil moisture. Then 1 minus Sm, Sm is the soil moisture index, and then this is the equation plus your error terminology. So, let us say the crop yield of a climate scenario is dependent upon primarily the number of days it is above certain threshold and the soil moisture, what is the level of soil moisture in there. So, basically so we are saying that it is a kind of a heat wave or hot extremes plus soil moisture deficit, or we can say sort of drought conditions. So, let us say if you remove this terminology, okay, we will be only simulating the effect of hot extremes. So, here we are simulating the effect of drought event. When we are combining with these two together, we are modeling the effect of hot extremes plus drought. So, basically let us take some numerical values and then we will be able to understand. Suppose this is example. So, suppose y max is equal to we have 4 tons per hectare. So, this is what we observed, maximum value of crop yield during non extreme conditions. And let us say we have observed the dt is equal to which is above a critical threshold, let us say 7 days. We have drawn the threshold, maybe threshold is let us say 40 degree centigrade, and above which we found there are 7 days which are crossing this particular threshold. Soil moisture is basically value of that particular region is let us say 0.5, which are moderate, okay, and the alpha t is equal to let us say this is we have already assumed 0.02, and this alpha s is basically sensitive parameter to the soil moisture is let us say we are assuming 0.3, okay. So, we put these values together here. So, that is y is equal to y max is 4 multiplied by 1 minus alpha t, which is 0.02 multiplied by 7 days minus alpha s is 0.3 multiplied by 1 minus sm, sm is 0.5, okay, with unknown terminology of the E we do not know, we will add, we can calculate in separate way E. So, this is how basically we can calculate. So, if we calculate further, y is equal to 4 multiplied by, so 1 minus this will become 0.14, right, 0.14 minus 0.3, 1 minus 0.5, this will become 0.5, 0.5 multiplied by 0.3, which is 0.15. So, if you calculate further, this is going to be 4 multiplied by 1 minus this is 0.29, and if you calculate it 4 into 0.71. So, that is coming out to be, if you calculate y is equal to 4 into 0.71. Okay, so this is coming out to be 2.84 tons per hectare. So if you compare when we have 7 days heat waves, when we have threshold crossing above 40°, and then we have moderate soil moisture conditions, our crop yield of that particular area is around 2.84. Now you can calculate what is the percentage loss we observed during the hot extremes and the drought conditions together in a certain region. So how do we do that? Let us say 2.84, right. We can take a difference between 4, because 4 is the maximum value, right. This is 4, it's the maximum value. So 4 minus this divided by, so this is basically divided by 4. So what we will get, multiplied by 100, 1 minute. So 4 minus 2.84 is equal to 1.16 divided by 4. We can further divide by 4 here, and that is coming out to be 0.29, and we can multiply it by 100, that is 29% of decline in the crop yield. If you are talking about compound extreme conditions where we have heat waves and we have the drought conditions as well. So as the number of days will increase, right, it will further reduce your it will further increase the y value, because if you multiply it with more number of days, it will be a bigger number. It would have a not higher, it would be have a lower value, right. So when we are talking about, let us say, if SM is further lower, it will also reduce your crop yield. If you have SM is higher, it will slightly improve the drought, the crop yield conditions of that particular region. So we can also model these separately. For example, we can only talk about heat extremes, and we can also talk about, let us say, so let us say y is equal to y max 1 minus alpha t, so multiplied by, let us say, dt. This is a one parametric equation. Let us say we can consider for only for hot extremes. Okay. So here if you understand, if you just, so this is a constant value, 1 minus alpha t multiplied by dt. Okay. As this dt will increase, this terminology will increase, this value will increase, and you will have a lower value, because let us say if it is close to 0.5, you will get 0.5. If it is, let us say, increasing 0.6, you will get 0.4. If it is further increasing, let us say 1.7, it is 0.3. So as this particular terminology will increase, overall this particular this term will decrease, and therefore as it is decreasing, then the value of this y value will also decrease. So it is basically y is inversely proportional to dt. So as the dt is increasing, y will be decreasing, like that. So this is a condition for hot extremes. Here we are also using the alpha t is a parameter which is close to 0.02, alpha t is 0.02. We can tweak this parameter, let us say, that will also affect your y value. So whatever parameters, whatever value we are using it here, that has to be monitored from the observed data set. Once we have observed data set from the different observations, then we can take it, and then based on that we would be able to calculate the crop yield difference during the particular hot extremes. Let us say if you further break it down, this equation for drought conditions, let us say this is Y max, okay, and for drought conditions we can say this is, let us say, 1 minus alpha s 1 minus Sm, okay. So basically, so this is a drought condition equation. Here it is depending upon the alpha s, we have used alpha s is equal to 0.3, okay, and the Sm. So as the Sm is decreasing, okay, so so basically this value will increase 1 minus Sm, and then basically you will have higher values for it is also depending upon this alpha s sensitive to this parameter, and that will basically tell you about how. So for example, if you take Sm is equal to 1, so in that category in this conditions y is equal to y max, okay, 1 minus alpha s 1 minus 1, okay, so that is basically 0. So y is equal to y max. So if you take, let us say, 0.9, that will be lower value. If we have taking lower value, it will be higher difference from 1, and therefore you will have lower yield compared to the y max conditions like that. So this is how basically we can try to make a very simple model which can use to predict the compound extremes or hot extremes or drought conditions on the crop yield, and then also can predict let us say in the normal conditions we have this much amount of crop yield of any particular crop in a particular region, and if the, let us say, hot extremes will occur or let us say drought will also occur at the same time, how this the crop yield value will change, and what is the relationship we can build from this particular data set. So this is a very simple mathematical model. You can try implementing these equations in Excel and MATLAB also, or Python, where you have a set of data set, you can input as an array in the data, and you have equation, and based on this particular equation you would be able to calculate what is the crop yield value for different types of scenarios. So here we have taken only one particular conditions, you can take multiple conditions, and then you can try to calculate what is the crop yield value for different types sets of scenarios like that, and then we can compare. You can also make plots out of it, and then you can see that how you can relate your y value, which is crop yield during the extreme conditions, with your different types of parameter you are selecting. Let us say in one case you have selecting alpha is equal to 0.3, in another case if you select alpha is equal to 0.4, and then you calculate the whole values, whole set of values, then alpha is equal to 0.5, and then you compare when you are taking alpha is equal to 0.3, 0.4, 0.5, how these values are behaving in the graphical way. Then you can relate with the real world scenario, and then you can say that okay, which appropriate alpha s value we should take, so that that will represent clearly the production of the crop yield in a certain region during different types of extreme weather. So another way we can also deal with, let us say you have crop yield data of wheat of any particular district of India, and you have also identified the hot extreme days, let us say years or months, and then you have also have a drought information. So you can separate out the crop yield information in two parts, 2 or 3 parts. One is for normal years, another for the drought years, and another for your heat extremes, hot extremes. And then you try to calculate let us say what is the average pattern of these different, and then you try to simulate using these particular types of modeling approaches, and then you can look at how this kind of simple model will be able to understand not completely the whole pattern. Maybe you can for more technical analysis, you may have to go with some sort of more rigorous analysis, that is a regression based analysis. That is, we can say that, let us say the crop yield is a function of some input variables that you can make. So these input variables can be your climate variable, or the land use, land cover conditions, and the soil type, and etc., soil moisture conditions, like that. You can also think about making some sort of ML model, and where you have some sort of x1 to xn. You can try to use some tree based regression or random forest, or some sort of XGB boost, like these. Those are algorithms you can use, and that can be used to predict how your crop yield are changing with the different drought or climatic extreme conditions. So I hope you have learned a very simple model of crop yield, and you can also able to simulate the crop yield conditions during the future climatic extremes or extreme climatic conditions, like that. And I hope you will also be able to replicate whatever we have discussed here. Can be one particular type of Excel or MATLAB or Python environment, and can be replicated in for multiple sets of the data set, and you can make some sort of graphical representation of this analysis, so that you would be able to understand how the different terminology which we have used in the methodology are interacting with each other and giving you certain results. So thank you so much for listening this particular tutorial.